Welcome to the second installment of Decarbonize Talks to People Who Know More Than He Does. Today's chat will be with a Canadian mining engineer who shares his thought on his channel, Dungeons, Deadlifts, and Decarbonization. We'll be focusing on decarbonization. Specifically, can we mine the materials needed to support the green transition? Triple D, welcome to Decarbonize. Why don't you start with introducing yourself and what brought you to launch your channel?
Yeah, thanks a lot. Like you said, my name's Dungeons, Deadlifts, and Decarbonization. It's a bit of a weird name. I realized the plan for the channel originally was to kind of cover Dungeons and Dragons or Pathfinder, the game that I play. I'm big into bodybuilding and powerlifting and things like that. And then decarbonization was kind of just the idea of like, these are the big things in my life and I want to talk about them. But I started my channel doing the decarbonization piece and talking about carbon taxes here in Canada and just seeing how kind of bad the discourse was on that topic. So I wanted to make a video kind of talking about that. And then I kind of fell in love with making the videos and doing all that. And I've kind of stayed the course with the decarbonization piece, but I'm going to move into probably weekly streaming where I can kind of chat with viewers and do those things. And I'll play video games and talk about lifting weights and the programs that I do and my Pathfinder games and things like that. So that's kind of where the name comes from.
Well, I've really enjoyed your talks on what's going up north of the border for us Americans. My wife's Canadian, so all of the political names are ones I know, and how you're ahead of us in many ways, including carbon taxes. And I applaud what's going on, and I really like your point of view. And to my viewers, I recommend checking out his channel, and there'll be a link to that in the description. What I really wanted to focus on are the minerals and materials needed for the green transition. We hear a lot about lithium, and a lot of people are worried, oh, can we make enough lithium for all the batteries? And personally, I'm less worried about lithium than some of the other materials. In part, that's because as we've seen EV production already ramp up, especially in China, but the mining industry has kept up with the production industry. And we've seen lithium prices have actually dropped recently and have definitely not gone up high as you would expect if there was a supply constraint. And the second reason is that we see a lot of alternatives coming online with sodium batteries and iron air batteries. And there are just so many different options, especially for the utility scale grid connected batteries, that if lithium prices do get high, I think we'll just see some of the batteries moving from lithium to other chemistries. And I'm wondering if you share that point of view, or do you think, no, there really is a concern on lithium?
I think it's maybe better to start a little bit more broad in our terminology. So the terms that we need to be considering are reserves, resources, and just kind of Earth's crust, like how much total metal is like in the Earth's crust. And so when we're talking about reserves, we're talking about the material that's economic right now to mine. And then resources are broadly just outside of that. They're kind of inferred resources. They might be interpolated through data, but we're like, we still have like a high degree of certainty. So usually you can bundle resources and reserves are the realistic amounts of like economic material right now. So given current prices, given the current case of things. But you can go way down that line where like economic copper is going to be between a grade or as low as a grade of like 0.3%, sometimes even as low as 0.2. But there's technically deposits that are like 0.007%. It's just a matter of like whether it's economically viable to actually mine that. So when we look at it from like the Earth's crust, we have enough minerals to decarbonize the planet without a doubt. Like it's not even a question. Whether it's economically viable is where we start to get into it, and then whether it's viable within the time frame of between now and 2025. And that's what's really important when we're looking at these concepts. So when we look at lithium, we're keeping up with production, but how much is the electric vehicle fleet right now? Yeah, it's leading current sales, but we have to think of this of how many vehicles do we have to replace? So right now, the number is about 1.4 billion vehicles, about 50% of which are like personal vehicles. and that is expected to approximately double by 2050.
Mm-hmm.
So not only do we have to replace all of the previously existing vehicles, but we also have to ramp up to that point. And so that's where we start to get into these like mineral demand questions, a significant change. So when we're looking at lithium or any of these minerals, it's not just right now, but it's like how many more times mining rate do we have to do? And something important about mining is it's like laced in regulations. There's a fair bit of NIMBYism when it comes to it. So we need to be really cognizant that it can take 10 to 15 years to even build a mine. So the decisions that we make today are going to affect whether we have that capacity later in the future, or if that capacity has to like upstep some regulations, which is not ideal.
Well, everything you said is immensely reasonable and a good paradigm to look at it. So given all that, is lithium not just for 2025, but 2030, 2035? Let's assume that internal combustion engine personal vehicles disappear by 2035.
Yeah.
Not from the road, but from new sales.
Yeah,
which I think is the kind of ballpark we're talking about. And assuming that we don't get a new chemistry for transportation, but we do for grid connected. So we're not, we don't need the lithium for the grid connected batteries, but they might still be the best chemistry available for mobile uses. Can we meet that demand?
In those cases, the IEA numbers are going to give you pretty good values. So they're probably stuff. I'll send you all the links. So whatever I say could be a little bit off because I don't have them up right now. But for things like lithium and graphite and cobalt and things like that, we're probably going to be looking in the order of like doubling to tripling in the high end for a lot of these minerals. But the IEA estimates are kind of in line with this. We're just kind of slowly replacing. Transmission and battery storage become almost negligible compared to electric vehicles. Electric vehicles by themselves is almost the entirety of the mineral demand, depending on the battery storage case that we're looking at. Assuming that we don't even need lithium ion batteries for battery storage, you're looking at like 90% of all the minerals we need are just to electrify our fleet.
Well, that's really interesting. I was thinking, the solar panels need certain trace minerals, the motors or the generators in the wind turbines need rare earth, and we need a lot of copper for the transmission.
You do, but it's just to a much lesser extent. And in terms of long line transmission, you can use aluminum in place of copper, and aluminum is so much more abundant in the crust in terms of like ramping up mineral production and scale. It's a lot easier. So anytime you can replace kind of copper or lithium or anything like that with concrete, steel, and aluminum, you're going to get really good returns because they make up so much of the crust and they already have huge capacities to actually account for these systems.
One of the interesting assumptions you said that he made, and I understand why he made the assumption, but it's a really very conservative assumption, is that with today's technologies, I mean, we've already seen cobalt was an issue in lithium batteries, and now Tesla is building EV batteries without cobalt. As things become constrained,
that's LFP, right? It's not NMC yet. I think NMC has gotten down to 1/9. The lithium ion still needs it. It's just the shorter range LFPs, I believe, are the ones that are without cobalt.
My point really is just as things become constrained, we find ways to engineer around that constraint. It's like what you said about copper. Well, copper is a constraint. We'll go to aluminum. There are many cases, and not always, where we can make the replacements. Permanent batteries needing rare earth neodymium. Hope I said that right. That's a hard thing to replace as far as I'm aware. And so we need the rare earths, and we don't have a good substitute for that. So
yeah, exactly. And actually, rare earths, to be honest, aren't even that bad on the end of things. They're called rare earth metals, but they're actually relatively abundant. To be fair, they kind of are a bit of a catch-all for a number of different minerals, but they don't seem to be quite as strained when you look at the numbers. Things like natural graphite is going to be like the biggest constraint because it seems to be the only economic anode that we have. Obviously, there's some new tech coming with like, silicon anodes, which I don't know if you're aware, but like they're looking at charge times of 6 minutes. And so when you're talking about technology, yeah, that's kind of this weird place that we're in. Is we can look at it from the mining perspective of like, okay, if we were to like snap our fingers right now and have this full throttle, we're building lithium ion storage batteries, we're building these cars, we're building all of the capacity that we need with the current technology, then it's a gigantic strain on the mining resources. But like you said, if we move to like sodium batteries, or if you have like a sodium battery with a silicon anode or a partial silicon anode and it can charge in 6 minutes, well, now even if it has only 100-kilometer range, who cares, because you can recharge it. It's still kind of obnoxious, but it's not nearly as obnoxious as like an electric vehicle right now. And then that gives you the benefit of like long distance haul trucking. Maybe you don't need as much of like an ammonia or hydrogen economy, because if you can charge really quickly, that seems to be the big constraint on long distance trucking. You'd still probably run into that issue with maritime shipping, just because you wouldn't have the charging points you need. So you still probably need the hydrogen economy over on that side. But probability of these technologies changing then changes the whole market dynamic around the mining side. And it makes it kind of difficult to estimate it, obviously. But I think what it does is help show like the change that needs to happen. Regardless, we need these technologies. Like how much or how conservative are these places being? I guess conservative might not be the right word, but like how able are they to switch to a different battery chemistry and start producing different battery types? Do we have some level of sunk cost fallacy with lithium ion? These are kind of the points of entry that I care a lot about. And then the other one being, you still have to build a shit ton of cars, basically building the existing fleet that we have and then doubling it. And like I said, that's where your mineral demand is. So it still puts a strain on copper. It still puts a strain on lithium and things like that, assuming that's still the route that we're going down. And so, where do you get the biggest bang for your buck? One of the biggest bangs for your buck is like densifying cities and increasing public transportation and just decreasing the need to actually build that many vehicles. That's like another avenue that you can go down. But then there's the technological avenue, which is like a big X factor in the whole situation.
A couple of years ago, my wife and I went from a 2-car family to a 1-car, 1 electric bike family. I have never been happier about it. It's like getting around town on an e-bike is so much nicer than getting around town in a car. We still like having a car for when we're going away for the weekend or we're doing a big shopping trip.
Yeah, exactly. And I showed that in one of my videos where it was like, if you reduce your car use by 65%, you're getting like on a mixed grid, you're getting a similar result to buying a Tesla on a totally hydro grid. With the current entrained carbon within building a Tesla right now. Obviously, as we become more renewable, all those kinds of things, it changes the total entrained CO2. But I'm just talking about right now. If I was to offer a suggestion for people, it would be, can you take transit? Can you get an e-bike? Can you do all these things? Like, obviously, living in big cities, that's going to be more practical. And that's why, like, for Canada's carbon tax, if you live in a rural area, you actually get a 20% boost in the carbon tax you see. So I get a little bit less because I live in a city, but people who have less opportunity to decarbonize their lifestyles get more back on the carbon rebates here, which I think is really good because I can cycle everywhere. I drive my car once a week at the absolute most.
It's pretty much the same with me. I even go to Costco on my bike and people look at me funny. The take-home message seems to be, don't worry about solar panels. Don't worry about wind turbines. Don't worry about long distance transmission. Don't worry about grid connected batteries as long as we get one of the new chemistries like sodium or iron based works out. Those are all going to be, in terms of getting the raw materials straightforward. EVs are the challenge. And the solution is we need to have fewer cars. That's not the way they're moving in China, where they're catching up to us in car ownership. The materials for EVs are going to be the challenge, but that it is a solvable problem, that the mining industry is ramping up for the materials needed for these EVs.
That's where I would have pushback because, again, it depends on the final outcome of, if we assume all things being equal, then I'd say the mining industry is wildly unprepared for the amount of electric vehicles we would have to build. But that's assuming that we don't have these X factor changes. Because again, it's not just building the existing fleet, it's replacing the whole historical one. And that's where I was saying like 10 times the mining demand for a mine that could take 15 years to get through all the regulation processes to even put the first shovel in the ground.
So going back to the assumption I made earlier that keep selling personal vehicles at the same rate we are, and in a fairly linear way, we transition from ICE to EVs between now and 2035. Or in 2035, there are no internal combustion engines sold. And then going from there forward, internal combustion engines are just replaced as they would naturally. That we're not doing an accelerated replacement.
I guess, again, I'm just saying, if we were to replace all of our systems and meet the new demand by 2050, then that's going to substantially strain the mining industry.
Mm-hmm.
So, I guess, yeah, in terms of this assumption, I'm not sure if that's following like the IEA trajectory, which I think is wildly underestimating the numbers. Well, I mean, it is wildly underestimating the numbers. Like I said, a total rejig of our entire transportation fleet significantly strains mineral demands with current technology. I think that's the important aspect. But we've seen technological advancement go really quickly and change. And like I said, these silicon graphite anodes could really shake up that dynamic. As far as I know, they're not economic right now, but the American military is really excited to have fast charging, silent electric tanks. So,
yes,
so when we're thinking about these things, it's like, okay, the American government is investing in basically stealth tanks and things that can run on electric battery.
Well, and also getting oil or diesel to forward operating bases is incredibly difficult. And it's a large chunk of the logistics is just diesel. So if they could put up panels, a portable wind turbine out at a forward operating base to charge up the vehicles, that's going to be a lot easier than the tanker trucks.
And as far as I know, they're kind of doing like hybrid systems right now, where it's like a twin engine. So you'll have the diesel backup, but then you run the electric motor as much as you want. Like, I mean, even in the mining industry, right? Electric engines have been used in shovels for decades now because you get more torque, and those shovels need to dig through like tons and tons of rock, right? So we've already partly electrified like our mining fleets and things like that, because there's a lot of really powerful benefits to electrifying systems outside of wanting it for the global scale. And I think the more times that we can sell decarbonization in other avenues that are mutually beneficial, kind of the better we'll do in selling it as an idea.
Do you have a sense of what minerals are going to be the most constrained replace?
I would say probably cobalt. It looks like cobalt probably eats through all of its reserves and resources. Copper probably eats through all of its reserves. Things like platinum and palladium, we talked about the hydrogen economy a little bit, will eat through a lot of that. But things like rare earth metals, we're looking at probably only like 1 or 2% of its reserves, but a pretty big increase in the rate at which it has to be mined. Things like that can change. Lithium, again, being something that's mined at like 130 kilotons per year right now, probably has to go up to 1,300 kilotons per year. So like a 10 times increase, which admittedly isn't the hardest thing in the world for lithium, because lithium mining is done 2 different ways. It's either through something called spodumene, which is like a flotation-based system, or basically these salt flats where you just send it out and it evaporates from the sun, and then which is where lithium kind of gets a bit of a dirty rap. That can be scaled up pretty efficiently because it's not really dependent on infrastructure.
Yeah. Doing it at high altitudes in the Andes, so it's not exactly.
Nevada now has the largest lithium deposit, that type, to my understanding.
That's being mined actively, or are they just developing it?
I don't know if it was just discovered, but I was seeing news articles about it very recently about Nevada now having the largest lithium deposit on the planet.
We won't run out of lithium. We just have to build the plants to extract it.
Exactly. A lot of this constraint is just simply like as much as I don't want to like get the mining processes like super quick and then sacrifice safety, it's like, okay, is there red tape that we can go through more quickly? Like NIMBYism is definitely an issue, right? I don't want to mine close to me. Like it's obviously not as bad as nuclear, where it's like, oh, like we're going to put a nuclear like waste facility 300 kilometers away from you and 2 miles underground, and that person still complains and you can't do it, right? Like it's not quite to that extent, but it still suffers from a huge amount of NIMBYism, and so the faster you can get through some of these other processes, like do you have standard systems? Are there can you like put committees together that are specifically designed around, okay, is this mine practical? Is it viable? Is it safe? Are they following all these protocols? All of these things, and really get all your ducks in a row to achieve the mining throughputs that you need. Canada being literally part of America's critical minerals plan, we're just like included. It's actually quite funny that we're essentially part of America when America thinks of these big problems.
That does not surprise me at all. I want to really thank you for your time and your insights, and also for your channel. And again, I recommend everyone go take a look at it. There's some great stuff there. And I've definitely learned a lot, and I'm hoping we can do this again.
Yeah, I'd love to. Maybe I'll be on the other end asking you questions. But yeah, I really appreciate it. And yeah, like you said, you can come check out my channel. And yeah, I definitely learned a lot from you as well. We've had some great offline conversations. I'm happy to have a few more online ones and get the information out there. But thanks, buddy.
Okay, thank you.